Okay, today we're looking at more trig functions, trig ratios, specifically sine and cosine. Yesterday we looked at tangent. Today we're looking at sine and cosine. You recall our acronym SOHCAHTOA. And you'll remember that the sine ratio is equal to the opposite side over the hypotenuse. That's where we get the SO. The cosine ratio is the adjacent leg over the hypotenuse, and the tangent ratio is the opposite side over the adjacent side. So that's where we get SOHCAHTOA. So looking at this triangle we have here, the sine ratio is opposite over hypotenuse, so we're looking at sine A, which is angle A. Now remember, this, from the perspective of this angle, it's going to have either an opposite side, an adjacent side, and then there's the hypotenuse. Well, the hypotenuse, which I'll label with an H, it's not going to change regardless of the angle I'm looking at. It should be a right angle. But the opposite and the adjacent sides do change depending on whichever angle I'm looking at. Now from angle A, the opposite side from angle A is going to be this segment right here. The adjacent side is the one right next to it. Sorry, not an H, it should be an A. Okay? That's where we get hypotenuse opposite adjacent. It's opposite because it's opposite angle A, and it's adjacent because it's adjacent to angle A. It makes up angle A. So if we're looking for the sine ratio, we're looking for the opposite, V, over the hypotenuse, Z. And that's my sine ratio for angle A. Now my cosine ratio for angle A is the adjacent leg over the hypotenuse. So the adjacent leg was X, and the hypotenuse is still the same no matter what, it's still Z. So those are the ratios for the sine and cosine ratios for angle A. Now, if we're looking at, and actually let's go ahead and erase that. We'll kind of look at it now from a different angle's perspective, and that's going to be angle C. So we're looking for the sine of C. Now, the sine of C, Z is still going to be the hypotenuse, but now X is going to be opposite angle C, so now that segment is the opposite segment, and V is now adjacent. Again, the sine is going to be opposite over hypotenuse, so the opposite side was X, the hypotenuse is Z. Now the cosine ratio for the same angle is going to be adjacent over hypotenuse. The adjacent side is V over hypotenuse, which is still Z. Okay, so that's how we come up with the ratios for the different angles. Let's look at an example of how to use this. So, here we've got angle 63 right here. We have to figure out which ratio we're dealing with. Well, the easiest segment to find is the hypotenuse because it's opposite the 90-degree angle. Now, we also have this 12, which is not adjacent, it's opposite to our segment, or to our angle 63. So we're dealing with O and H. Which ratio deals with that? That would be sine. So what we're going to do is we're going to find the sine of 63 degrees, and that ratio, the sine ratio, is opposite over hypotenuse, which would be 12 over x. And that's our equation. From here, it's identical to yesterday's assignment. we would multiply times x, and when we did that, we would be left with this. Now we still want to solve for x, so we'll divide by sine 63. That would cancel this out, and x is equal to 12 divided by sine 63. And when we plug that into our calculator, we get 13.5. All right, so now let's look at another example. Example 2, I have a missing angle here. So if I have a missing angle, we're going to have to find that angle. That's the angle. That's the x. That's the variable what I'm missing. Now, what are my knowns? I have 15, which is my hypotenuse. It's opposite my 90-degree angle. And then I've got 12, which is adjacent to the angle that I'm looking for. So that would be my adjacent side. So which ratio uses adjacent and hypotenuse? As far as SOHCAHTOA, that would be the cosine ratio. So we're going to find the cosine of x, and that's going to be equal to my cosine ratio of adjacent over hypotenuse, which is 12 over 15. And you'll remember this is where I use the second button, and I'm going to hit cosine, because when I'm trying to find my angle, I use the inverse. So your calculator is going to look like this. Now what do we put in there? We put 12 divided by 15. And when you put that into your calculator, we're going to round to the nearest degree. X equals 37 degrees. And that's your answer. Excuse me. Let's look at example 3. So, here, what do we have? We have a missing angle right here. Now, what is the information that we are given? 18 is my hypotenuse. 6 is across from angle x, so it's my opposite. Which ratio uses OH? Well, that's going to be so we're going to use sine. So we're going to find the sine of x and set it equal to the sine ratio of angle x, which is opposite over hypotenuse, 6 over 18. This again, we're going to use the second sine feature, the inverse. And in your calculator, it should look like this. You're going to put 6 divided by 18. And rounding to the nearest degree, we find that x is equal to 19 degrees. All right, looking at the last example of our notes, we've got 15 degrees here. This is the angle that we're looking at. 12 is going to be our hypotenuse. And x is opposite the 15 degrees. What ratio uses O and H? That would be the sine ratio. So, sine of the angle, which is 15 degrees, is equal to the sine ratio. Opposite over hypotenuse. Opposite is x. Hypotenuse is 12. Well, get rid of that fraction. Multiply by 12. And we're left with x equals 12 times sine of 15, which when we put that in our calculator, we solve for x to the nearest tenths place, we should get 3.1 as our answer. And that's how you find the missing sides or angles of a right triangle using sine and cosine ratios. Let's take a look at the assignment similar to our previous day's assignment. Okay, 1 through 4, just a little practice using your calculator to find the ratios. All you're hitting is sine 67, enter, and getting an answer. Now, number 5 through 8, we have a missing angle. This is where we're going to use the second and either the sine or cosine button. So you would hit, for number 5, you would hit second sine and your calculator should look like this. Then you'll put in 0.8988. Enter, and it will give you your answer. Again, round to the nearest degree, which is the nearest whole number. On 1 through 4, you're going to round to the nearest 10,000th place, which is 4 places past the decimal. All right, and then when we get 9 through 12, all you're doing here is you're just writing the ratio down. You're not solving for any side or any angle. Number 9, just use that one as an example. We're looking for the sine of angle C. So angle C, the 50 is going to be the hypotenuse. In relationship to angle C, what side is opposite angle C? That's going to be 30. What side is adjacent to angle C? That's going to be 40. Now for sine, you'll remember that's the ratio is going to be opposite over hypotenuse. We're going to find the opposite side, which we found was 30, over the hypotenuse, which is 50. And that's all we have to do. We just have to find the ratios there. Okay, number 10, you're going to find the cosine of angle C, which, remember, the cosine is adjacent over hypotenuse. Okay, so the adjacent side to angle C would be this side, and of course the hypotenuse is going to be opposite the 90-degree angle. All right, 13 through the back page, 22, these problems we're solving for a missing side. So we'll look at number 13 real quick as an example. We've got this angle, which is 48 degrees. We've got our hypotenuse, which is what we're looking for. And 12 is our opposite side. What ratio uses opposite over hypotenuse? Sine ratio, so we are going to use the sine ratio of 48 degrees. That's equal to opposite 12 over hypotenuse x. And then from there, you'll solve for x. So this is how you come with your equation from your picture. Again, multiply times x, which gives us x times the sine of 48. And then we'll divide by sine 48. All right? And the last section we want to talk about is 23 through 30. This section is dealing with missing angles. So just a quick refresher. This is the one, and again, nearest degree or whole number, where we're going to hit second. And depending on the ratio we're using, it's going to either be cosine or sine. All right? So looking at 23, the angle that we're missing is right here. Now what are the sides that we know? Opposite the 90, this is the hypotenuse. This is the leg that's adjacent. So what ratio uses adjacent and hypotenuse? That would be cosine. So we're going to find the cosine of our angle, which is unknown, our x. And the ratio is adjacent, 51, over hypotenuse, 54. We're going to hit second cosine, which our calculator is going to look like that, and we input that with 51 divided by 54. Hit enter, you get your answer, rounding it to the nearest degree. That angle is 19 degrees. And that's it. All right, hopefully this helps with the assignment and you get a better understanding of sine and cosine.